What if I told you that Einstein's most famous thought experiment, like the absolute foundation of modern physics, might actually contain a massive, glaring blind spot?
Oh, wow. A blind spot in Einstein's work.
Yeah, and simply because he forgot to account for the biological reality of the human eyeball.
I mean, that is a massive claim. We are so used to, just trusting the clean mathematical perfection of theoretical physics.
Right, totally.
So the idea of a biological glitch messing up our understanding of space-time, it sounds, well, almost absurd.
It really does sound absurd. And yet, that is exactly what we're exploring today. So welcome back to another deep dive.
Glad to be here.
I am so thrilled you are joining us today because our mission is to completely upend how you think about observation, reality, and the speed of light itself.
And we are getting into some really unique source material for this one, right?
Oh, absolutely. The source material we're pulling from today is not like some peer-reviewed academic journal. It is a wonderfully eccentric, highly technical, and meticulously detailed Japanese blog post.
The title alone is great.
It is. It's titled Draft: Einstein Slacking 143 Answer 009, The Lie of the Light Clock.
It's just incredible. And, the author of this post uses an incredibly bizarre but effective toolkit to make their case.
Yeah, they really do.
They aren't just relying on standard chalkboard equations. They use a 3D rendering software called Blender.
Which is like animated software.
Exactly. They use that, plus deep biological facts about the human visual cortex and, of all things, the battlefield hierarchy of ancient Chinese military strategy.
It is a wild ride. But before we get into Chinese generals and 3D sandboxes, we really need to set the stage here.
Right. We need the basics first.
Yeah, because to understand why this blogger is claiming Einstein was, slacking, we have to make sure we actually understand what Einstein built in the first place.
We need to talk about the classic light clock thought experiment.
Exactly, which is like the bedrock of special relativity.
It really is. I mean, Einstein wanted to prove that time is not absolute. Time moves differently depending on how fast you're moving.
Right.
And to prove this, without, having to build an actual spaceship, he used a thought experiment involving a theoretical clock made of light.
So for everyone listening, imagine a train. A glass train moving forward on a track at a constant, incredibly fast speed.
A very fast train.
Right. And inside this train, there's a clock. But it's not, a grandfather clock. It literally just consists of two mirrors facing each other.
One on the floor, one on the ceiling.
Exactly. And a single photon of light bounces straight up, hits the ceiling mirror, and bounces straight down to the floor. Up, down, tick-tock.
Right. And for the person standing inside that moving train, the light just goes straight up and straight down. It travels a perfectly simple vertical path.
Tick-tock.
Yeah. But now, put yourself in the shoes of an observer standing outside on the platform, watching the train zoom by.
Okay, so I'm on the platform.
Yeah.
The train flies past.
Right. For the person on the platform, the light isn't just moving up and down. Because the train is moving forward, by the time the light travels from the floor to the ceiling itself has moved forward in space.
Oh, right, because the whole train shifted.
Exactly. So the light has to travel on a diagonal path to actually hit it. It forms the zigzag pattern, up on a slant, down on a slant.
Okay, you can picture that, a zigzag.
And here is the absolute genius of Einstein. The speed of light is constant. It never, ever changes.
Right, that's the golden rule.
But the person on the platform sees the light traveling a much longer diagonal distance than the person on the train who just sees it go straight up and down.
Because diagonals are longer than straight vertical lines.
Exactly. So if the speed is exactly the same, but the distance is longer, then the only way the math physically works out is if time itself slows down for the moving train.
Time dilation.
Boom, time dilation.
It's just a beautiful, elegant geometric proof. You draw an XY axis on a chalkboard, you draw that diagonal zigzag line, use a little Pythagorean theorem, and boom, you have unlocked the secrets of the universe.
It's incredibly clean. And physicists have relied on this exact geometric mental model for over a century.
Which brings me to the blog post.
Yeah.
Okay, let's unpack this. Because the author looks at this perfectly clean thought experiment and basically calls foul.
They completely reject it.
Yeah. They don't just ask us to imagine the scenario differently in our heads. They actually built a literal 3D space constructed in Blender to tear it apart.
They built a digital sandbox. It's a localized, mathematically strict environment to simulate actual reality.
Right.
In this 3D space, the floor is set at an elevation of z equals 0, and a ceiling is set at z equals 10.
Okay, so a 10-unit high room.
Exactly. And inside this perfectly defined box, a light ray is fired, bouncing between the floor and the ceiling at a strict 45-degree angle.
But the author isn't actually interested in the bouncing light itself, right?
Right.
They are totally obsessed with how we are observing the bouncing light.
Yes, the observation is the key.
So they place 3 specific cameras in this 3D space, and they name them after historical Chinese figures from the Han Dynasty.
Which is such a weird but great detail.
It really is. Camera 1 is named Han Xin, and Han Xin was like the legendary frontline general, the guy in the mud.
Right, in the action.
Yeah, so this camera is stationed right at the origin coordinates, 0, 0, 0, 0, where the action starts.
Okay.
Then camera 3 is named Liu Bang. He was the founding emperor. So his camera's floating way up high at coordinates 0, 0, 20, looking down from on high.
It's the ultimate top-down perspective, literally the God's eye view.
Exactly. But the camera the author really wants us to focus on is camera 2. And this one is named Xiaohe.
And he was the strategist, right?
Right. Historically, Xiao, he was the brilliant military strategist and logistics officer. He wasn't on the front lines, and he wasn't the emperor in the sky.
Mm.
He managed information.
So he had to wait for reports.
Yes. So his camera is positioned at an offset. The coordinates are x is 0, z is 1, but y is -10. He is stationed away from the main axis of action, just waiting for the visual reports to come in.
What's fascinating here is that this specific placement camera 2 out on the axis is the author's core critique of modern physics.
How so?
Because theoretical physicists almost always look at problems from Liu Bang's perspective. The emperor.
The God's eye view.
Exactly. The mathematician draws that 2D plane on a chalkboard, the x and z axis of the bouncing light, and just assumes an immediate, perfect, simultaneous understanding of everything happening on that plane.
Okay, but pause for a second. I'm looking at this Blender setup, and I just have to ask, why did they make this so incredibly complicated?
It does seem like a lot.
I mean, naming cameras after Han Dynasty emperors, putting them in -10 on the axis. Are we really saying Einstein, like the father of relativity, just forgot how space works and we need a video game engine to prove it? Isn't that a massive, almost arrogant leap for an anonymous blog post to make?
It totally sounds arrogant until you dig into the mechanics of what Zhao he actually represents.
Right, I'm listening.
The universe doesn't actually work like a chalkboard drawing. You cannot observe an event from a God's eye view in reality.
Because you're a person.
Right. By creating Xiaohe, the information officer positioned off to the side at y equals -10, the author is forcing us to acknowledge a gritty, undeniable physical reality.
That we are stuck in one place.
Yes. In the real world, an observer is a physical entity made of matter, and that physical entity has to wait for information, in this case light, to physically travel across space to actually reach them.
Oh, wow. So you can't see it instantly.
No. You cannot observe the light clock ticking until the photons from that event crop the physical distance of the y-axis and actually hit your detector.
And the math textbook just ignores the axis entirely.
Completely ignores it. Zhao. He forces us to measure that delay.
You know, the author's insistence on mapping this reality perfectly is almost intimidating. While going through the blog, I found this incredible aside that just blew my mind.
Oh, the font thing.
Yes. The
Yeah.
font thing. The author literally included a step-by-step tutorial in the middle of this intense physics thesis on how to fix a very specific font issue in the Blender software.
Well, which seems completely unrelated, but it's so telling.
It is. They explain how to dig into Blender's user interface preferences and manually link a local Windows font file, just to ensure that the word reflection,
Which is Hansha in Japanese.
right, just to make sure Hansha displayed perfectly in a Japanese kanji font, rather than defaulting to a slightly different Chinese font where, like, the first stroke of the character is angled differently.
It just shows you the mind of the person constructing this argument. They refuse to accept even a single pixel of misrepresentation in their simulation.
It's pure perfectionism.
Yeah, because to them, if the visual data is wrong, the entire premise is corrupted.
And if they care that much about a single pixel in a 3D simulation, it makes total sense they'd turn that exact same magnifying glass on the human eye itself.
Oh, absolutely.
Because this intense obsession with rendering the physical world with absolute precision leads the author to their next major argument, which is that despite our desire for precision, human perception is fundamentally a lie.
A total fabrication.
Yeah. Biologically speaking, Our brains are constantly deceiving us.
And the author maps out the exact biological timeline of human sight to prove this. It totally shatters the illusion of real-time observation that physicists rely on when they draw up these thought experiments.
Let's actually break down this timeline for everyone. Say you are looking out a window at a set of train tracks.
Okay, simple enough.
At time equals 0, or t equals 0, light leaves the object. It physically bounces off the train tracks outside.
Right.
Then at t equals 1, that light physically passes through the glass of the window pane.
Still outside your head.
Exactly. Then at t equals 2, the light finally arrives at the fovea, which is the very center of the retina at the back of your physical eyeball.
So the light has now finally reached the biological hardware, but, and this is crucial, you still aren't actually seeing it yet.
Not even close. It isn't until t equals 3 that the primary visual cortex, V1, and the higher visual areas in the back of your brain finally finish taking that raw light data, sending it through your neural pathways and processing it into conscious recognition.
It takes physical time for those electrochemical signals to travel and be computed.
Yeah, the brain has to do the math.
And here is where the grand biological deception really occurs. At t equals 3, your brain effectively pretends that all of that processing time simply didn't happen.
Just hides it.
It totally hides it. At t equals 3, your brain projects what the author calls a movie theater inside your mind. It makes you genuinely believe that you are seeing the window and the train tracks exactly as they exist at this current exact moment.
Even though you aren't.
Right. It artificially syncs the delayed visual input with your current physical awareness. The brain completely throws away strict space-time reality just to protect you from the overwhelming cognitive burden of constantly calculating sensory delays.
You know, it's exactly like watching a live stream on your computer or your phone.
Hmm.
The user interface stamps this bright red live badge in the corner of the video, so you feel like you're experiencing the concert or the game in true, instantaneous real time.
That's a great analogy.
But in reality, the camera captured the light seconds ago. That data was compressed, sent through miles of fiber optic cables, routed through servers, uncompressed, and then buffered by your device's CPU.
So much happens in between.
Right. Your brain is essentially putting a fake live badge on a buffered, delayed reality.
Yes. The CPU of your computer and the visual cortex of your brain are doing the exact same thing. They are hiding the latency to give you smooth, usable experience.
Which is helpful, mostly.
Oh, it's great for surviving daily life and, not tripping over your coffee table. But it is a catastrophic flaw if you are a theoretical physicist trying to define the fundamental laws of space-time based on your immediate perception of an event.
Wow. Okay, which brings us back to the core tension here. We have a Blender simulation of Chinese generals, and we have this deep dive into the latency of the human visual cortex.
Right.
How do these actually collide to break Einstein's clock?
They collide right at the drawing board. According to the author, theoretical physicists essentially fell for the brain's live stream trick.
Oh, I see.
Think back to the physicists standing on the platform observing the light bouncing on the train. How are they actually observing it?
Well, they just visualize the geometry strictly in their heads.
Exactly. They assume immediate geometric apprehension. The author points out that these physicists skip the fundamental physical requirement of actually letting their retinas, as they put it, take a bath in the light.
Take a bath in the light. That phrasing is so visceral.
It really is.
It forces you to remember that light is a physical thing that has to wash over you. It's not just an idea.
If we connect this to the bigger picture, the crux of the argument is that by doing the math purely mentally, physicists are isolating a flat 2D plane.
The Z and X axis, where the light is bouncing up and down and moving forward.
Right. But they're completely failing to calculate the physical delay of that light traveling outward along the axis to actually reach the physical observer's eye on the platform.
Because they think they're seeing it live.
Yes. They are confusing the brain's instantaneous movie theater projection for actual physical chronological observation. They assume because they can picture the whole graph at once, the light information arrived at all points on the graph at once.
Okay, here's where it gets really interesting. Because the author doesn't just make this as some philosophical complaint. They actually ran the numbers in their Blender sandbox to prove the discrepancy.
They did the math.
Yeah, they pulled the exact hard data generated by the script for camera 2. Our military strategist, Xiao He, who was sitting out there on the axis waiting for the light to reach him.
And that data reveals the hidden reality of the axis.
It really does. In the simulation, the light starts at the floor and hits the ceiling at a 45-degree angle. The coordinates for that reflection point on the ceiling are X equals 10, Z equals 10.
Right, the peak of the bounce.
Exactly. Now, the true physical time that the reflection occurs in the box is t equals 14.142. That is the exact moment the event happens in objective reality.
Okay, 14.142. But Xiaohe, camera 2, is stationed away from the action.
Right.
He has to wait for the light from that specific reflection to physically travel across the axis to his lens.
And the light from that exact reflection doesn't actually reach the strategist until t equals 30.905.
Which is a huge difference.
It's more than double the time. The event happens at 14.142. The observer doesn't even know it happened until 30.905.
Right.
But I still need you to ground this for me, though. Why does a delay matter? We know it takes time for light from distant stars to reach us, but that doesn't break our understanding of astronomy. Why does this delay break Einstein's chalkboard math?
It's because of what the author calls the lost angle. This is why the critique is so sharp.
Okay, the lost angle. What is that?
In traditional theoretical physics, to make the math easier and cleaner, they often establish a local coordinate system. They basically tether the observer to the event, effectively collapsing the distance.
They just erase the gap.
Exactly. But when you simplify the math by deleting the observer's true physical distance on the y-axis, you lose vital, hard physical data.
You lose the specific angle of the incoming light.
Yes, Xiao. He isn't just receiving light late. He is receiving light from a specific physical angle that dictates where the object was in the past, not where it is right now.
Oh, I see.
If you just collapse the space into a local coordinate system, if you treat the observation as simultaneous with the event, you erase the physical truth of the light's journey.
You're cheating the math.
You are. You are no longer calculating the physics of reality. You are calculating the physics of a mathematically convenient imagination.
You're basically deleting the buffering time and pretending the live stream is actually live.
Exactly.
And to really drive this home, to illustrate the difference between a physical event and our observed evidence of that event, the author brings up Charles Wilson's cloud chamber.
Such a brilliant analogy.
It is. For those who might not be familiar, a cloud chamber is basically a sealed environment containing a supersaturated vapor of water or alcohol.
Just a box full of dense mist.
Right. And when an invisible charged particle, like a cosmic ray, shoots through this chamber, it ionizes the gas. The vapor condenses around these ions, leaving a ghostly white trail of mist.
It's one of the earliest ways physicists could physically see some atomic particles.
But the key word there is see, in massive air quotes, because as the author points out, we never actually see the invisible cosmic ray itself.
No, it's way too fast.
Yeah. The particle is moving far too fast. It is long gone by the time we register anything. We only see the physical reaction it left behind, the white trail of alcohol vapor.
We see the wake of the boat, not the boat itself.
Exactly. And the author maps this perfectly onto the light clock thought experiment. We don't actually see the light ray bouncing simultaneously between the mirrors in the clock.
Our eyes just aren't capable of it.
Right. Our physical eyes cannot capture a God's eye view of the entire apparatus in real time. What we actually do is reverse engineer the event.
We wait for the delay.
Yes, we wait for the delayed light to cross the y-axis, hit our physical retinas, get processed by our visual cortex at t equals 3, and then our brain constructs a 2D path in our minds.
We are totally confusing the white trail of vapor, the delayed mental reconstruction for the cosmic ray itself.
And the author argues that Einstein's math models the white trail of vapor, not the actual physical truth of the photon bouncing in the box.
Which really raises an important question about how much of our accepted physical laws are based on mathematical abstractions rather than actual physical mechanics.
That's a scary thought.
It is. The cloud chamber proves that observation is a physical process with physical delays. The strategist, Zhao, he proves that information takes time to cross a battlefield.
You can't just ignore it.
No, you cannot substitute a mathematical point on a graph for a biological retina without losing the reality of the axis.
So what does this all mean? We've traveled from a digital blender box to ancient China, through the visual cortex, and into a cloud of alcohol vapor.
It's been a journey.
It really has. Tying all of these wildly different sources together, what is the ultimate conclusion we are supposed to draw from this deep dive?
The core takeaway is that true physical observations simply cannot be entirely replaced by mathematical abstraction.
You can't just math your way out of reality.
Exactly. When physicists try to explain the universe purely through thought experiments and clean chalkboard geometry, they risk falling victim to their own biological wiring. They rely on a brain that has literally evolved to edit out latency.
Wow.
The author is reminding us that you must always account for the physical reality of the strategist waiting for the message to arrive. If you ignore the time it takes for the light to physically take a bath in your retina, your equations might be beautifully balanced, but they are completely detached from the physical reality of space and time.
It really makes you reconsider the confidence we place in our own perceptions, let alone the foundations of theoretical physics.
It absolutely does.
Well, thank you so much for joining us on this incredibly mind-bending journey today. We love taking these deep dives with you, tearing apart the complex layers of how we understand the world.
It was a blast.
And before you go, I want to leave you with a final, lingering thought to build on what we've unpacked today. We talked about how our brains are constantly running a delayed movie theater simulation to protect us from the overwhelming reality of sensory lag, right?
Right.
We edit out the delay to create a seamless interface for reality. But as we move further into the future, we are increasingly relying on artificial intelligence and machine vision systems to observe the world for us,
Oh, that's true.
from self-driving cars to automated defense networks. If human observation is fundamentally flawed, because we construct a localized, fake, real-time coordinate system in our minds, are we unconsciously programming our AI systems to make the exact same biological mistake?
Oh, wow.
Are we teaching machines to trust the white trail of vapor instead of measuring the invisible cosmic ray? Keep that in mind the next time a machine tells you it knows exactly what is happening right now.